In this lesson, we are going to look at Pythagoras theorem. Now, this is just the theorem that can be used to find one of the missing sides of a right-angled triangle. So let's begin by drawing this right-angled triangle. So a right-angled triangle is a triangle that has one angle equal to 90 degrees. So here we have this angle of 90 degrees. Now the distance across the 90 degrees is known as hypotenuse. Then the remaining two sides are known as adjacents. Or sometimes you may find them to be written in books as legs of a right-angled triangle. Now, what you need to know about these distances are the hypotenuse is the longest of the three distances of a right-angled triangle. Now, let's look at the formula behind the Pythagorean theorem. So let's say we have this right-angled triangle here. So we have this distance A and this distance B, then we also have this C. So for the formula is C squared is equal to A squared plus C B squared. So the point is, if we are solving for the value of C, we just have to square A plus C, the square of B, then the square root of the sum of the square of A and B is the value of C. Now let's put this information into practice. So let's say we have a right-angled triangle with the distances. We begin with, we have 3 and 4. Now if the question is find the value of x, so if we can use the formula, here this is our A, our B and our C. So the formula is C squared is equal to A squared plus C B squared. So our C squared is X squared is equal to A squared is 3 multiplied by 3 plus 4 times 4. So X squared is equal to 3 by 3 is 9 plus 4 times 4 is 16. So if we add 16 plus 9 is 25. So we can now find the square root of x squared. Here also the square root of that. So x is equal to 5. So the pattern here is, if you square 3 squared is 9, 4 squared is 16. Then if we add 9 plus 16 is 25. So the square root of 25 is 5. Because we know that if we square 5 squared will give us 25. So 25 is equal to 16 plus 9. Okay, let's have another example. Now we are going to use the same numbers that we use. Now let's say this time we want the value of A. Here we have this 4. Now if we are looking for one of the adjacents, the key is we need to square 5 squared minus 4 squared. Then we find the square root of the difference between the square of the two numbers. So if we want to put this into practices, we can say this is our C. So C squared is equal to A squared plus C B squared. So C squared is 5 squared is equal to A squared plus C 4 squared. 5 squared is 25 is equal to A squared plus 4 squared is 16. So if we collect the like terms, will be 25 minus 16 is equal to A squared. So 25 minus 16 is 9 is equal to A squared. So if we find now the square root of 9, so A is equal to 3. So we can say that if we are looking for one of the two adjacents, the pattern is the difference between the hypotenuse, the square of the hypotenuse, and the square of the other adjacent given. Now let's see if we can find another way we can find this a squared. So this method that I'm trying to use, that might be simple for some of you, is make sure for you to use this formula, make sure you are looking for one of the adjacent. The formula that I'm about to use, or the principle, the concept that I'm about to use, can only be applied if you are solving for one of the adjacent. So the pattern is, we can look at, we are looking for a squared. So what you can do is, we need to add 5 plus 4. You add the two numbers, multiply by 5 minus 1. So a squared is equal to 5 plus 4 is 9. 5 minus 4 is 1. So a squared is equal to 9 times 1 is 9. The square root of this one, the square root of this one. So we can see that we are getting the value of a. Now let's also maybe, let's say this time we have, let's just change the numbers. So let's say here we have 3, then let's say we are looking for 4. We are solving for 4. So this is our b. So for us to find b, since b is one of the adjacent, so we can say b squared is equal to, so we add 3 plus 8, sorry, 5 plus 3 multiplied by 5 minus 3. So here we have squared. 5 plus 3 is 8. 5 minus 3 is 2. Then b squared is equal to 8 times 2 is 16. Then we can find the square root of b squared and also the square root of 16. So we can see that we are able to get our b. Okay, now let's also have some more examples. Okay, so we'll begin. We have this triangle here. So feel free to pause the video, you give it a try. Now this time, let's say here we have 12 and 5. Then we are solving for this value here. Let's say we have also another, the same triangle, but for this one we assume we have 13, 5. Then we are solving for y here. Okay, so then the third one, we have the same one. We have our 12, 13. Then we can put our, let's just say m. Okay, so let's look at the first pattern here. If this is our a, b, and sorry, this should be our c, then our b here. So the formula is c squared is equal to a squared plus b squared. C squared is equal to a squared is 5 times 5 plus c 12 times 12, or 12 squared. So c squared is equal to, here we have 25 plus 144. C squared is equal to 25 plus 144 is 169. Then we introduce the square root, also here the square root. So c is equal to 13. So for us to find the value of c, you just have to square the two adjacents, add them, and find the square root of each. Now let's solve for y. This is our a, b, c. So here we are solving for adjacent. So we are going to say y squared is equal to, so we are going to add 13 plus 5. Then 13 minus 5. So y squared is equal to 13 plus 5 is 18. 13 minus 5 is 8. Then y squared is equal to 18 times 8. I'm getting 144. Then the square root of 144 is just 12. So let's look at m. We have a, b, c. So m is adjacent, so we can say m squared is equal to 13 plus 12, then 13 minus 12. So m squared is equal to 13 plus 12 is 25. 13 minus 12 is 1. So 1 times 25 is 25. Square root of 25 is 5. So m is equal to 5. So now you can see that we've seen the pattern behind the Pythagorean theorem. Now, away from this, let's say we have another right angled triangle. For this right angled triangle, we have the distance of 10 centimeters. Then here we have 80 centimeters. So from the concept that we've gotten, we can find the missing distance. In our case, let's use A, B, C. So if we have if we are using letters like this, so we can first begin with AB, because AB is the distance indicating the longest distance, is equal to AC squared plus BC squared. AB is 10 centimeters squared. AC is what we are solving for, plus BC is 8 centimeters squared. So 10 times 10 is 100 centimeters times centimeter squared. Here is AC squared plus C, 64 centimeters squared. So if we collect the like terms, this will give us 100 centimeters squared minus 64 centimeters squared is equal to AC squared. So if we subtract 100 minus 64, will give us 36 centimeters squared is equal to AC squared. So introduce the square root. Also here the square root. AC is equal to 60 centimeters. So here we have a 60 centimeters. So, and it's making sense because 6 times 6 is 36. 8 times 8 is 64. 10 times 10 is 100. So we can say that 36 plus 64, we are getting this 100. Now, if we want to use the other method that I showed you, we can say AC squared is equal to, we are going to say 10 plus 8 times 10 minus 8. So AC squared is equal to 10 plus 8 is 18. 10 minus 8 is 2. 2 times 18 is 36. Square root of 36 is 6. So AC is equal to 6 centimeters. So this is how you can simplify or find the answer using the Pythagorean theorem. Now there are also what we call the Pythagorean triples. So this gives us how numbers move. So the first one is 3, 4, 5. Then the second pattern is we get 5, 12, 13. Then we also have 7, 24, 25. We have 9, 40, 41. Then we get 11, 16, 61. 13, 84, 85. Then here we have 6, 8, 10. We may also have 8, 15, 17. So from this Pythagorean triples, these longest numbers like 5, 13, 25, 41, 61, 85, 10, and 17. These are hypotenuse. Then the other remaining two represent the two adjacents. So if we want, we can prove the first one. 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9 plus 4 squared 16 is equal to 25. 16 plus 16 is equal to 25 is equal to 25. You can try the second pattern is 5 squared plus 12 squared is equal to 13 squared. 5 squared is 25, 12 squared is 144, 13 squared is 169. So 25 plus 144 is 169, which is equal to 100. So these numbers, they are able. Let's try for 7. 7 squared plus 24 squared is equal to 25 squared. 7 squared is 49 plus 24 squared. This is giving me 576. 25 squared, I'm getting 625. So let's add 49 plus 576. I'm getting 625.